are going back to the moon. In this episode of Astral Adventure, we covered the historic launch of the NASA Artemis II mission, marking the first time humans have traveled to the moon in over 50 years. Watch as we detail the 10-day journey of the Orion spacecraft and the SL rocket carrying Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and CSA astronaut Jeremy Hansen. We explored all the mission goal orbiting the moon, testing critical system, and paving the way for a sustainable human presence on the lunar surface. The roar of the engine wasn't just a sound. It was a physical weight pressing the crew into their seats inside the Orion capsule. The four astronauts, Reid, Victor, Christina, and Jeremy, watched through the thick glass as the Florida coastline shrinks into a patch of green and blue, then vanishes into the velvet black of the vacuum. Astral Adventure. This is Houston. You all go for translunar ejection. With a sudden silence, launch the SL rocket upper stage ignited. They weren't just orbiting Earth anymore. They was falling towards the moon. Days later, the moon stopped being a flat white disk in the sky and became a world. As they swung around to the far side, the dark side that human eyes has never seen in person for over a half a century. The radio went dead, total silence. Beneath them lays a blotted landscape of craters and jagged mountains, illuminated by a harsh silver sun. Look at that, Victor whispered, pointing out the window. A tiny, brilliant marble was rising over the lunar horizon. Earth, everyone they had ever known, every city, every ocean, was contained in that fragile blue glow. They wasn't landing, not this time, but as they fired the thrusters to begin the long loop back home, they knew they had opened the door. The path was clear. Next time the boot will hit the dust. The Artemis II mission was a historic 10-day crew lunar flyby that successfully concluded on April the 10th of 2026. It was the first time humans traveled to the vicinity of the moon since the Apollo 17 mission in 1972. Mission overview and key milestone. Launch in trajectory. Launch on April the 1st, 2026 from the Kennedy Space Center. The Orion spacecraft followed a hybrid free return trajectory to the moon, a lunar flyby in distance. On April the 6th, the crew flew within 4,067 miles of the surface, viewing the far side and setting a new human distance record of 252,756 miles from Earth. Key moments. The mission included observing a 54-minute solar eclipse behind the moon and a successful safe splashdown in the Pacific Ocean on April the 10th. The crew. The mission featured a historic, diverse crew, including Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Jeremy Hansen, making several firsts for space exploration. And so we have put together this clip about 30 to 45 minutes long on NASA and the mission to the moon. Clip is going to be highlighting some of the what we think is some of the significant great moments during the mission to the moon. So one will have to ask what exactly was the purpose of the mission to the moon, specifically to the dark side. And that is that NASA is they was going to build a space station to orbit the moon, but then later decided to actually build or put billions of dollars into actually building a space station on the surface of the moon itself. And so actually what they're trying to do, or what they're trying to set up, is eventually they want to go to Mars. And what better way to launch a mission to Mars than to launch it from lunar itself? Or if you launch a mission to Mars from Earth, undoubtedly that's going to be a one-way trip, for you're not going to be able to get back due to the distance. But if you build a space station there on Luna, over time you equip that station and supply it with the things that you need. It's going to take several missions of going back and forth from the Earth to Luna to bring supplies, rocket fuel, and all kinds of things that they're going to need in order to launch this great mission to Mars. So from the moon to Mars, they can now launch this mission. And then they can also get to the moon. And once they get back to the moon, which have a station, then they will be able to return back to the Earth. Other than that, you will have a one-way trip, which is basically nothing more than a suicidal trip. I call it a suicidal trip because your loved ones will never see you again. And so you will never get back. And we're not able to exactly stay on Mars for a long period of time. But eventually they want to build a colony of 1 million people on Mars. I don't know what they are gearing up to. Makes me think that something is wrong with our Earth. They're thinking that we might need to one day leave our home planet. So this mission is set to take place in 2030. Right now we are in 2026. So we still have quite a few years left for them to prepare and build this station for this great mission to take place. So in my eyes, is I don't know if they see something, the scientists, when I say this, the scientists and the astronauts, all the experts, they might see something about our own planet that they feel that one day we will have to leave this planet and go to another planet. And so how are you going to pull that off is baffles me. But I'm quite sure by the time that happens, I probably won't exist anymore, being that I'm already approaching my middle 60s. And so the people that are here left after I'm long gone is going to have to contend with this. But from what I know and what I understand is one day our sun will no longer exist, or it's going to explode, or it's going to get so big to where all of the other planets that is rotating around it, including Earth, we're going to be eventually evaporated into our sun as she grows bigger and bigger. But fret not none, worry not none, because that you're talking about 4 to 5 to 8 billion years when the sun probably will eventually play out, if that is so to be. For all we know, the power that created the sun, it could also, undoubtedly have higher knowledge and understanding than what we have. And the sun can recreate itself, or the power to be that created the sun, which we call God. I'm quite sure it knew all these things and had all these things in place. And so who knows, what we think may not be so, because we only have a limited knowledge of the sun and the earth in our universe. And so we put together this video. Hopefully you will enjoy it. 35 to 40-minute video. The mission NASA has successfully completed 10-day trip around the moon, lunar, what you call it. So hopefully you will get something out of this video. So sit back, relax, enjoy it. Share, subscribe. Feel free to leave a comment or a question that you might have about NASA, the moon, our planet, or the universe. Or if you have a knowledge that you'd like to share yourself on the universe, it'd be greatly appreciated. I'm John Schaff, your host. We thank you for watching. Enjoy the video, the presentation, and we'll see you in the next one.
We are going back to the moon. In this episode of Astral Adventure, we cover the historic launch of NASA's Artemis II mission, marking the first time humans have traveled to the moon in over 50 years. Watch as we detail the 10-day journey of the Orion spacecraft and the SLS rocket, carrying Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and CSA astronaut Jeremy Hansen. We'll explore the mission's goal, orbiting the moon, testing critical systems, and paving the way for a sustainable human presence on the lunar surface. The Artemis II mission was a historic 10-day crewed lunar flyby that successfully concluded on April 10th, 2026. It was the first time humans traveled to the vicinity of the moon since the Apollo 17 mission in 1972. NASA.gov mission overview and key milestones. Launch and trajectory. Launched on April 1st, 2026 from Kennedy Space Center. The Orion spacecraft followed a hybrid free return trajectory to the moon, lunar flyby and distance. On April 6th, the crew flew within 4,067 miles of the surface, viewing the far side and setting a new human distance record of 252,756 miles from Earth. Key moments. The mission included observing a 54-minute solar eclipse behind the moon and a successful safe splashdown in the Pacific Ocean on April 10th. The crew. The mission featured a historic, diverse crew, including Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Jeremy Hansen, marking several firsts for space exploration. The primary purpose of going to the moon under the Artemis program is to establish a sustained human presence on the lunar surface, moving beyond the flags and footprints of the Apollo era to create a long-term base for science and exploration. Key objectives include 1. Preparing for Mars. The moon serves as a critical test bed for deeper space travel, technology testing. NASA is using the moon to perfect life support systems, habitats, and radiation shielding in a deep space environment. Operational training. Learning to live and work on another world is essential for future crewed missions to Mars, where returning to Earth is far more difficult too. Scientific discovery. The moon is a time capsule that preserves the history of our solar system. Geological research. Scientists are targeting the lunar South Pole, a region believed to contain water ice in permanently shadowed craters. Fundamental science. On-site human explorers can conduct more sophisticated field geology and sample collection than robotic rovers alone. 3. Economic and strategic leadership. The program aims to foster a new lunar economy through commercial and international partnerships. Resource utilization, finding and using lunar resources like water ice for fuel or oxygen, is vital for making space travel sustainable and cost-effective. Global alliances, through the Artemis Accords, over 60 nations are collaborating to establish a common set of principles for peaceful and transparent space exploration. Inspiration. Like Apollo, Artemis is designed to inspire the Artemis generation to pursue careers in STEM and maintain national leadership in space. NASA.gov. 4. Inclusive exploration. A core goal of the program is to broaden human representation in space, including landing the first woman and the first person of color on the moon. Natural History Museum. The recently completed Artemis II mission, April 2026, was a foundational step, testing the Orion spacecraft and SLS rocket with a crew for the first time to ensure these systems can safely transport humans to and from the moon. NASA's focus for the Artemis program has shifted significantly as of early 2026. The agency is moving away from orbiting platforms to prioritize a sustained surface presence at the lunar South Pole. Target landing sites. NASA has identified several candidate regions near the lunar South Pole for future landings, such as Artemis IV, the first scheduled landing, currently targeted for early 2028. These sites are chosen for their proximity to permanently shadowed regions, PSRs, that may contain water ice. Key candidate regions include Malapert Massif, a massive mountain that provides nearly perpetual sunlight for power, yet overlooks deep shadowed craters. Peak near Shackleton, located almost directly at the South Pole, offering a unique vantage point for observing ice-bearing craters. Mons Mouton Plateau, a wide, flat area that could support future base expansion and large-scale rover operations. Nobile Rim. Sites on the crater's rim vary significantly in elevation, offering diverse geological sampling opportunities. Key technologies and program pivots. The Ignition Initiative, announced in March 2026, marks a major strategy shift. Gateway Space Station. Paused. NASA has effectively canceled or paused the Lunar Gateway, the planned orbiting space station, to redirect roughly $20 billion toward building a permanent surface base. Next-gen spacesuits. Astronauts will use the Axiom Extravehicular Mobility Unit, Axiom-U, which is more flexible and resilient than previous designs, specifically for the harsh lunar dust and cold. Lunar Terrain Vehicles, LTV. New commercial rovers, such as Intuitive Machines Moonracer and Astrolab's Flex, are being tested at Johnson Space Center. These will allow astronauts to explore much farther from their landing craft than during the Apollo missions. Human Landing Systems, HLS. NASA is partnering with SpaceX, Starship HLS, and Blue Origin, Blue Moon to provide the transport from lunar orbit to the surface. Updated mission timeline Artemis II, April 2026. Crewed flyby mission, currently in progress, recently completed. Artemis III, mid-2027. Now a crewed rehearsal in Earth orbit to test docking with landing systems rather than a surface landing. Artemis IV, early 2028, targeted as the first crewed lunar landing of the program. NASA's strategy for the moon has shifted toward Project Ignition, a phased plan to build a permanent base by 2030. This strategy prioritizes the lunar surface over the previously planned orbiting gateway station, which has been paused to redirect $20 billion toward surface infrastructure. Scientific experiments for the first landing. The Artemis IV mission, targeted for early 2028, is currently set to be the first crewed landing of the program. Astronauts will deploy several high-priority instruments. LISTER, lunar instrumentation for subsurface thermal exploration with rapidity, a drill that will measure heat flow from the moon's interior to understand its thermal history. C-LINE, site-agnostic energetic lunar ion and neutron environment, an experiment to study how space radiation interacts with lunar soil. Regolith, to help protect future astronauts. Emilia 3D, emission imager for lunar infrared analysis in 3D. This will create 3D thermal models of the terrain to improve navigation and our understanding of regolith properties. Seismic Station, a station designed to monitor moonquakes, providing data on the moon's internal structure. Dust Tracking Rover, a specialized tool to study how abrasive lunar dust behaves around human activity, which is vital for long-term equipment maintenance. International partners and contributions. The lunar base is a global effort governed by the Artemis Accords, which now includes over 60 signatory nations as of early 2026. Japan JAXA, developing the pressurized lunar rover, a mobile home that allows astronauts to travel hundreds of kilometers across the surface without wearing spacesuits. Europe ESA, providing the European Service Module, ESM for the Orion spacecraft and the Moonlight program, a satellite network for high-speed communication and GPS-like navigation on the Moon. Canada CSA, contributing the Canadarm3 robotic system and a specialized lunar utility vehicle to help build and maintain the base. United Arab Emirates, UAE, providing an advanced airlock module for the surface habitat to allow astronauts to safely enter and exit the base. Next, major milestones: Artemis III, mid-2027, a rehearsal mission in Earth orbit to test docking between the Orion capsule and commercial landers like SpaceX's Starship and Blue Origin's Blue Moon. Artemis IV, early 2028, the first crewed landing at the South Pole. Artemis V, late 2028, the second crewed landing and the beginning of permanent base construction. As of April 2026, NASA has entered a new phase of exploration called Project Ignition, which prioritizes a permanent lunar base over the previously planned orbiting Gateway Station. Companies building the lunar base to achieve a sustained presence by 2030. NASA has transitioned its partnerships from orbital modules to surface infrastructure. Axiom Space, now the sole provider of the Axiom U spacesuits required for lunar walks. They are also developing habitation and airlock modules originally designed for their commercial space station that can be adapted for the surface. SpaceX and Blue Origin, both companies are developing human landing systems, HLS. NASA now uses a streamlined approach, selecting whichever lander is ready first for mission assignments to avoid further delays. LTV contractors, three main competitors, Intuitive Machines, Lunar Outpost, and Venturi Astrolab, are currently testing lunar terrain vehicles, LTV, at Johnson Space Center. International partners, Italy is slated to provide a primary habitat module. The UAE has committed to repurposing its airlock module for surface use. Japan, JAXA, continues work on the pressurized Lunar Cruiser rover for long-distance exploration. Astronaut training for the surface training has evolved from orbital simulations to high-fidelity surface rehearsals. Underwater simulations. Astronauts use the Neutral Buoyancy Lab, NBL, in Houston to practice moonwalks in 1/6 gravity and rehearse vehicle recovery operations. Extreme Environments, NEMO. NASA's NEMO program uses the Aquarius Reef Base underwater to simulate living in cramped lunar habitats and testing communication delays. Geological field work. Crews undergo intensive geology training in volcanic fields, such as those in Arizona, which mimic the rugged, cratered terrain of the lunar South Pole. Lava tube research. Future training may include navigating lava tubes, as researchers are currently designing concepts for using these natural structures as radiation-shielded warehouses or command centers. Updated mission path Artemis III, mid-2027. A crewed test flight in Earth orbit to practice docking with landers and testing new spacesuits. Artemis IV, early 2028. The first scheduled crewed lunar landing of the program. NASA is currently evaluating 3 distinct designs for its next-generation Lunar Terrain Vehicle LTV. Unlike the Apollo moon buggies, these new rovers are designed for both crewed missions and autonomous operation, allowing them to conduct science even when astronauts aren't present. Comparison of lunar rover designs. Each company has taken a unique approach to meeting NASA's requirements for speed, 9.3 mph, cargo capacity, 800 kg, and steep slope handling, 20 degrees. Company rover name, key features, and design philosophy. Intuitive Machines Moon Racer, the Speedster, a rugged, truck-like design with a roll cage structure and massive Michelin tires. It features a modular trailer for hauling an extra 800 kilos of cargo. Lunar Outpost Eagle. The Workhorse, designed like a heavy-duty tractor-trailer configuration with high ground clearance for extreme rocky terrain. Venturi Astrolab Flex, the Utility Hub, flexible logistics and exploration. Flex uses a modular deck system to swap different scientific payloads easily, acting as a pickup truck for lunar labs. Nuclear power, surviving the lunar night. To establish a permanent base, NASA must solve the problem of the 14-day lunar night where temperatures drop to 280 degrees Fahrenheit and solar power is unavailable. Through the National Initiative for American Space Nuclear Power, launched April 2026, NASA is developing the following: Fission Surface Power, FSP, a 100 kilowatt class nuclear reactor designed to provide continuous sun-independent electricity, SR-1 Freedom and LR-1. These Pathfinder missions, targeted for launch as early as 2028 and 2030, will test mid-power reactors capable of running life support, communications, and labs for at least 10 years. Thermal management. The reactors will use Brayton power converters to turn nuclear heat into electricity, ensuring the base stays warm and operational throughout the 2-week darkness. Current mission timeline as of April 2026. Artemis II, completed April 2026. Historic crewed flyby. Artemis III, mid-2027. Crewed rehearsal in Earth orbit with lander docking. Artemis IV, early 2028. Targeted first crewed landing at the South Pole. Artemis V, late 2028. First deployment of an LTV rover for crewed use. Establishing a permanent home on the moon requires moving from camping in a capsule to a robust, self-sustaining industrial operation. Here is how NASA and its partners are tackling life support and the simulation of these extreme environments. Life support, the closed-loop challenge. For a base to survive without constant and expensive supply runs from Earth, it must recycle almost everything. Oxygen generation, ECLSS. Future modules will use advanced environmental control and life support systems. These systems electrolyze water to create breathable oxygen and use Sabatier reactors to turn exhaled CO2 back into water and methane. The search for moon water. The base's survival depends on mining water ice from the South Pole. NASA is testing the Viper rover technology to locate these deposits. This ice will be melted for drinking water and split into hydrogen and oxygen for rocket fuel. Regolith shielding, to protect against solar radiation and extreme heat. Early base concepts involve using robotic 3D printers to cover habitats with lunar regolith soil. This provides a natural insulation layer that can withstand the moon's temperature swings. Earth-based training and simulation sites. NASA doesn't just train in labs. They use analog sites that mimic the lunar surface's geology and isolation. Pisces, Hawaii. The volcanic basalt fields on the Big Island are chemically and physically similar to lunar soil. Teams use this site to test robotic 3D printers and oxygen extraction hardware. Craters of the Moon, Idaho. This national monument serves as a training ground for lunar geology. Astronauts learn to identify high-value mineral samples while wearing bulky, pressurized suits. The Black Rock Desert, Nevada, its vast, flat, and dusty expanse is used to test the autonomous navigation of the LTV rovers, Moonracer, Eagle, and Flex in low-visibility, whiteout conditions. McMurdo Station, Antarctica. While not geologically similar, the isolation and extreme cold provide the perfect psychological analog for a small crew living in a nuclear-powered habitat during the 14-day lunar night. Key base infrastructure. The Project Ignition plan focuses on building the Artemis base camp in stages. Foundation stage, 2028-2030, deployment of the 100 kilowatt fission surface power reactor and the first unpressurized LTV habitation stage, 2030 plus, arrival of the foundation surface habitat, led by Italy and the US, allowing crews of 4 to live on the moon for up to 60 days at a time. To build a home on the moon, NASA is moving away from shipping heavy bricks and toward living off the land. Here is how they plan to build the base and feed the people inside it. Robotic construction, 3D printing the base. Shipping construction materials to the moon is too expensive, so NASA is investing in situ resource utilization, ISRU, using lunar soil, regolith as ink. Project Olympus. NASA has partnered with Icon, a construction tech company, to develop a massive 3D printer that can operate in a vacuum. It uses a high-powered laser to melt regolith into a ceramic-like material. Layered defense. Robots will first 3D print landing pads to prevent rocket exhaust from sandblasting the base. Next, they will print protective shells over inflatable habitats to shield astronauts from radiation and micrometeorites. Autonomous builders. These robots are designed to work while humans are away, preparing the site and building roads and power lines so the base is plug and play when the next crew arrives. Food systems, more than just space paste. On a 60-day mission, menu fatigue is a real psychological risk. NASA is developing a hybrid food system for the Artemis base camp, advanced packaged meals using pressure-assisted thermal sterilization, PATS. NASA can now create shelf-stable meals that taste much closer to home-cooked food than traditional dehydrated pouches. The Space Garden Hub plant habitat. While most calories will come from Earth, the base will include a lunar greenhouse. Microgreens. Astronauts will grow nutrient-dense crops like radishes, kale, and lettuce using hydroponics or aeroponics, growing in air mist. Psychological boost. Beyond nutrition, the smell of living green things and the act of gardening are vital for mental health in the sterile lunar environment. Biomanufacturing. Research is underway to use yeast or algae to print specific nutrients or even protein-rich snacks on demand, reducing the weight of food shipments. Updated mission milestones. Artemis IV, early 2028. First landing. Astronauts will test early food systems and robotic site prep. Artemis V, late 2028. First delivery of the 3D printed landing pad infrastructure. Artemis VII, 2030. Expected completion of the first permanent foundation surface habitat. Living on the moon for months at a time is as much a mental challenge as a physical one. To support this, NASA is building a high-tech communication network and a rigorous psychological support system, the Lunar Internet, LunaNet. For a permanent base, NASA can't rely on the old point-to-point radio used during Apollo. They are building LunaNet, an internet-like framework for the moon. Moonlight Program, ESA. The European Space Agency is launching a constellation of satellites to provide high-speed Wi-Fi and GPS-like navigation across the lunar surface. 10-11. High-def streaming. Astronauts will be able to stream 4K video back to Earth and use augmented reality, AR headsets, to receive real-time repair instructions from ground control. 5-12. Safety beacon. LunaNet will provide a constant 911 service, allowing any astronaut or rover to broadcast their location even if they are in a deep crater out of direct sight of Earth. 10. Psychological training. The Right Stuff 2.0. Living in a small hab during the 14-day lunar night can lead to cabin fever and depression. NASA uses specific strategies to keep the crew sharp. Ice training. Astronauts are selected for their ability to handle isolated, confined, and extreme environments. They undergo teamwork under stress training, where they are deprived of sleep and forced to solve complex puzzles as a group. 1-3. Sensory simulation. To combat the sterile gray environment of the moon, habitats will use circadian lighting that mimics Earth's 24-hour day-night cycle and scent emitters, like the smell of rain or fresh-cut grass, to trigger positive memories. 6-11. Virtual reality, VR, escapism. Astronauts use VR to visit their families or walk through a forest on Earth, providing a vital mental break from the claustrophobic base. Next steps in the mission: Artemis III, mid-2027. Testing the first iteration of the AR headsets and suit-to-suit Wi-Fi in Earth orbit. Artemis IV, early 2028. The first landing crew will deploy the LunaNet beacons at the South Pole. The Artemis II mission reached its final milestone this month. On April 10th, 2026, the crew successfully splashed down in the Pacific Ocean after their 10-day historic journey around the moon. The Artemis II crew. The crew made history with several firsts during their flyby. Commander Reid Wiseman, NASA, the mission commander and oldest person to travel to the moon. Pilot Victor Glover, NASA, the first person of color to travel to the moon. Mission Specialist Christina Koch, NASA, the first woman to travel to the moon. Mission Specialist Jeremy Hansen, CSA, the first non-American to travel to the moon. Backup crew, NASA's Andre Douglas and the Canadian Space Agency's CSA, Jenny Gibbons, served as the designated backups. Legal rules for the moon. As nations move toward permanent bases, the legal framework is evolving through international agreements and domestic laws. Property and land ownership, national appropriation prohibited. Under the 1967 Outer Space Treaty, no nation can claim sovereignty or own the moon. Safety zones, the Artemis Accords, now signed by 61 nations, including recent signatory Oman, establish safety zones around operations to prevent harmful interference between different countries' bases. Land versus infrastructure. While you cannot own the land, nations and private companies can own the hardware and infrastructure, habitats, rovers, and landing pads they place on the surface. Mining and resource rights extraction is lawful. The U.S. and its partners maintain that extracting lunar resources, like water ice or minerals, is legal and does not count as appropriating the moon itself. Ownership of extracted material. Under the Artemis Accords and the U.S. Space Resource Exploration and Utilization Act, once a resource is removed from the moon's surface, the entity that extracted it holds the property rights to that material. Scientific sharing. Signatories of the Accords agree to share their scientific findings with the global community, even if they are engaged in commercial extraction. Current program outlook. Following the success of Artemis II, the baton now passes to Artemis III, targeted for mid-2027, which will be a critical rehearsal in Earth orbit to test docking with landing systems before the first planned boots hit the lunar dust during Artemis IV in 2028. The Artemis II mission successfully concluded this month with the crew splashing down in the Pacific on April 10th, 2026. This success has shifted the global focus toward the upcoming surface race between the U.S.-led coalition and the China-led International Lunar Research Station, ILRS. The Artemis II backup crew. The backup crew was highly integrated, training alongside the primary team for over 2 years to be ready to fly on a moment's notice. Andre Douglas, NASA, a former U.S. Coast Guard officer and systems engineer who backed up the 3 American astronauts. He is considered a strong candidate for a seat on the Artemis III crew. Jenny Gibbons, CSA, a combustion engineer who backed up Jeremy Hansen. Following the flight, she served as a lunar Capcom at NASA's Mission Control, becoming the first international partner astronaut certified to hold this critical communication role for a lunar mission, the global lunar competition, Artemis vs. ILRs. The lunar surface is now divided between two competing international blocks, each with its own set of rules and timelines. Feature Artemis Accords, US-led ILRs, China-led, lead nation United States, NASA, China, CNSA, founding partners, 61 nations, including Japan, ESA, Canada, Russia, founding, Belarus, Pakistan, Egypt, status of Russia, no involvement, diminishing role due to terrestrial conflicts, key milestones, Artemis IV crewed landing, early 2028, Chang'e 7 robotic landing, August 2026, governance accords focus on safety zones, focus on shared infrastructure and data potential conflicts at the South Pole, as both programs target the same high-value real estate, specifically the water ice-rich Shackleton crater. Several friction points are emerging. De facto, property rights. The Artemis Accords establish safety zones to prevent interference. However, critics and ILRS members argue these zones could act as territorial claims in disguise, which is forbidden by the Outer Space Treaty. Competing standards. If the ILRS and Artemis blocks operate under incompatible technical or legal frameworks, it could lead to accidental interference or blocked access to critical resources like water ice. Robotic precedents. China plans to land the Chang'e 7 mission at a permanently illuminated peak near Shackleton in August 2026. This first mover advantage could complicate NASA's planned landing sites for later missions. Following the success of Artemis II, the next major milestone is Artemis III in mid-2027, which will now serve as a crewed rehearsal in Earth orbit for landing systems. As of April 2026, the lunar race is intensifying. While NASA recently completed the crewed Artemis II flyby splashdown April 10, 2026, China is preparing its most complex robotic mission yet, Chang'e 7, to land at the South Pole later this year. China's Chang'e 7 mission launch August 2026. This mission is a flagship endeavor intended to directly confirm water ice and prepare for a future permanent base. The landing site, the primary target, is a permanently illuminated peak on the rim of Shackleton crater. Key scientific instruments: mini hopping probe, the Scout, a novel robot designed to hop into permanently shadowed regions, PSRs. It carries a water molecule analyzer to drill for and analyze ice and volatiles in situ. Rover and lander, equipped with a lunar penetrating radar to map subsurface structures and a seismometer to detect moonquakes. International payloads includes a wide-field telescope from the International Lunar Observatory Association, USA, Hawaii, to capture images of the galactic plane, and a Russian instrument to detect lunar dust and electric fields. NASA's new training facilities and simulations. To prepare for the extreme conditions of the South Pole, NASA has moved beyond traditional desert training to advanced digital and physical simulations. The PIT Lab prototype immersive technologies located at Johnson Space Center. This lab uses virtual reality (VR) to simulate the unique long shadow lighting of the South Pole. Astronauts use these simulations to learn how to navigate using shadows as a compass, since there is no GPS on the moon. The Connecting Ridge simulation. NASA meticulously simulates the terrain between Shackleton and De Gerlache craters, a top-tier candidate site for the future Artemis base camp. Shadow cam data integration. High-resolution imagery from NASA's Shadow Cam, which can see into total darkness, is now used to create high-fidelity maps for astronaut geological training, allowing them to identify specific boulders and craters in pitch-black terrain. analog geological sites. Crews continue to use the Cinder Lake field in Arizona, where NASA used explosives to create a crater field that perfectly replicates the scale and distribution of the South Pole landscape. Following the success of Artemis VI, NASA is pivoting toward the technical challenge of mining the moon and finalizing the team for the next big step: water extraction technologies. Since shipping water costs thousands of dollars per gallon, both NASA and China are testing ways to pull it from the lunar soil. Trident drill. Developed by Honeywell, the regolith ice drill for exploring new terrain, is a 1-meter drill designed to pull up frozen soil. It will be a key part of the upcoming robotic missions to find high concentration ice zones. The Polar Resources Ice Mining Experiment Prime 1. This tech uses a mass spectrometer to sniff out chemical signatures of water and other volatiles as they evaporate from the drill site. MOXIE-style extraction. NASA is researching thermal extraction, which involves heating lunar soil in a sealed chamber to bake the water out as steam, which can then be condensed and purified for drinking or split into hydrogen, oxygen for fuel. Artemis III rehearsal crew, mid-2027. While NASA has not made the official announcement for the Artemis III Earth orbit rehearsal, several top-tier candidates are currently in lead roles within the astronaut office. Andre Douglas, after serving as the backup for Artemis II, he is the leading candidate for a pilot or mission specialist seat. Jessica Watkins, a geologist who has spent significant time on the ISS. Her expertise in field geology is critical for landing site evaluation. Zena Cardman, currently serving in leadership roles for lunar training, she is highly likely to be on one of the first surface-bound mission rehearsals. Anne McClain, a veteran astronaut who has been heavily involved in the development of the new Axiom spacesuits. The new strategy, NASA has confirmed that Artemis III will no longer land on the moon. Instead, it will be a high-stakes docking and duration test in high Earth orbit. This mission will prove that the Orion capsule and the SpaceX Starship HLS can dock, transfer crew, and support life for extended periods before the first actual landing attempt on Artemis IV in early 2028. As of April 2026, the successful splashdown of Artemis II on April 10th has cleared the way for the program's most technical phase yet. NASA is now focused on the Artemis III docking rehearsal, targeted for mid-2027, and the final development of the technologies that will enable a permanent lunar base. The new Axiom U spacesuits. The Axiom U, Axiom Extravehicular Mobility Unit, is a radical upgrade from the suits used during the Apollo and Shuttle eras. Mobility and dexterity. Built with innovative soft and hard joints, the suit allows astronauts to walk, bend, and kneel with ease, avoiding the bunny hop movement of the Apollo missions. Extreme protection, designed specifically for the lunar South Pole. It can withstand temperatures ranging from 250 degree hours in direct sunlight to 330 degree hours in shadowed regions for at least 2 hours. Enhanced visibility. The helmet features an Oakley-designed visor with 24-karat gold coating to filter harsh radiation and 4 integrated lights to combat the long, deceptive shadows at the pole. Redundant life support. The Portable Life Support System, PLSS, provides 8 hours of oxygen and features dual redundant loops to prevent single-point failures. Smart Tech. The suit includes an onboard diagnostic system for vitals tracking, HD cameras, and integrated 4G LTE connectivity to hook into the lunar